Welcome back to the Geometry International Honors Summer Assignment Help video series. In this video, we're going to work some examples of solving quadratic equations by factoring. There are many ways to solve a quadratic equation, but in geometry, the method that we will use most often is to solve quadratic equations by factoring. So let's take a look at this first example. We have x squared plus 6x minus 27 equals 0. So if we're going to solve it by factoring, we need to start by factoring this trinomial. So I'm going to go ahead and write two sets of parentheses, because what we're looking for when you factor a trinomial is you're looking for the two binomials you multiply together to get that trinomial. So in the first term in each of these binomials is going to have to be x, because x times x is x squared. So let's go ahead and put an x here and an x here. And then I always look at this sign right here because it tells me about the signs of the two binomials. Remember that negative 27 is the product of these two constants. So if I multiply the two constants together and get a negative number, that tells me that the signs are different. So I'm going to put a plus here and a minus here, and then I will look for factors of negative 27 that add up to positive 6. So make a list if you need to, but eventually you should come up with positive 9 and negative 3. If I were to multiply positive 9 and negative 3, I would get negative 27. If I would add them, I would get positive 6. So that means we'll factor this plus 9 and minus 3. Sorry for my sloppy handwriting. Okay, now at this point, we're going to use a property. It's an important property called the zero product property. Let's just write that down. It's called the zero product property. And here's what that property says. It says if I multiply two things together and get 0, then one of those two factors has to be 0. If I multiply a times b and I get 0, what that tells me is either a equals 0 or b equals 0. All right, so let's use that property here. I am multiplying two things together and the result is 0. So what that tells me is either the first factor, either x plus 9 is equal to 0, or my other factor, x minus 3, would have to be equal to 0. X minus 3, oops. Let me fix that, sorry. X minus 3 is equal to 0. So now what we'll do is we'll solve these two little equations and get our two solutions. This equation, since 9 is being added to x, we will subtract 9 from both sides. So one of our solutions then is x equals negative 9. And then the other solution will solve this little equation. We'll just add 3 to both sides. So I'm going to add 3 to both sides, okay? And then my solution, I'm going to write it over here, is x equals 3. So our two solutions are x equals negative 9 and x equals positive 3. Here is another example where we're going to solve a quadratic equation by factoring. This one is a lot like the last one. It's just that the factoring will be a little bit more challenging because of this leading coefficient of 5. So if you recall how we factored a quadratic where that leading coefficient, the coefficient of x squared, is something other than 1, we started by multiplying the leading coefficient, let me see if I can fix that. The leading coefficient 5 times the constant term. So 5 times negative 2 is negative 10. I'm just going to write that over here. Then what we're going to look for are factors of negative 10 that add up to negative 3. So two numbers such that when I multiply them, I get negative 10, but their sum is negative 3. And those two numbers would be negative 5 and positive 2. So what we're going to do is we're going to just take this middle term, this negative 3x, and I'm just going to rewrite that as the sum of negative 5x and 2x. So I'm going to rewrite this trinomial, but now it's going to be 4 terms because I'm basically just splitting up that middle term. So it would be 5x squared. Instead of writing minus 3x, I'm going to replace that negative 3x with minus 5x plus 2x, and then keep going. Minus 2 equals 0. So now when you have 4 terms, the way we factor 4 terms is to use a method called factoring by grouping. So I'm going to group the first 2 terms together, and then I'm going to group the second 2 terms together, and then factor a common factor out of each group. So this first group, 5x squared minus 5x, and those 2 terms have a common factor of 5x. So I'm going to factor that 5x out of just those 2 terms. That means I divided out of each term. So 5x squared divided by 5x will give me x, and then minus 5x divided by 5x would be minus 1. All right, and then let's look at our second group. Our second group of terms has a common factor of positive 2. So I'm going to factor a positive 2 out of these 2 terms. So I will write plus 2 times, and 2x divided by 2 is x, and then negative 2 divided by 2 would be minus 1, and all of that is equal to 0. Okay, so now what I want you to notice is these 2 kind of mega terms, these big terms, have a common factor of x minus 1. So that's going to be one of our factors when we factor this trinomial. So I'm going to pull out that x minus 1. What remains in the first term? Well, if I take out the x minus 1, a 5x remains. And then take a look when I factor out an x minus 1 out of this term, a 2 remains. So that would be plus, that would be plus 2. And that's all equal to 0. So now we'll use that zero product property that says if I have 2 terms, if I'm going to multiply 2 terms together and get 0, one of those factors has to be 0. So either x minus 1 equals 0, in which case x would be 1 when I added 1 to both sides, or 5x plus 2 equals 0. Now let's solve that little equation. I'm going to subtract a 2 from both sides, and we get 5x equals negative 2, and then we'll divide both sides by 5, and so that solution would be x equals negative 2/5. In this next example, I want you to kind of analyze this trinomial. Before you start doing, you might want to do the process we did last time, where we multiplied our leading coefficient times the constant. But before we do that, I want you to look closely at the first term and the last term, and notice that the first term and the last term are perfect squares. 4x squared is a perfect square, and its square root is 2x. 9 is a perfect square, and its square root is 3. And then if we multiply 2x times 3 and get 6x and double that result, we'll get the middle term. So in other words, I hope you notice that this trinomial looks like this pattern: a squared minus 2ab plus b squared, where the first term and the last term are perfect squares, and the middle term is the result of taking these square roots, a and b, multiplying them together and doubling to get the middle term, okay? So if you have a trinomial that fits this pattern, it's going to factor into a minus b quantity squared, okay? So that makes this factoring very simple. Since this trinomial is a perfect square, okay, and the square root of the first term is 2x, the square root of the last term is 3, that means it's going to factor simply into 2x minus 3. Now the reason why it's minus 3 is because of this sign right here. So it's 2x minus 3, quantity squared. All right, so then to solve that equation, let's think about what that means. What that means is 2x minus 3 times 2x 2x minus 3 equals 0. That's what it means to square something. Okay, so when we think of the zero product property, I have two factors that I'm multiplying together to get 0. So one of them has to be 0. Now, the factors are the same, so I only need to solve one little equation. I just need to take one of those factors and set it equal to 0 and then solve. So we'll add 3 to both sides, and we'll get 2x is equal to 3, and then divide both sides by 2, so x is equal to 3/2. So this problem only has one solution, and it's x equals 3/2. So in this next example, if we're going to solve it by factoring, I want you to notice that the left side of the equation is of the form a squared minus b squared. So let me write that pattern over here, a squared minus b squared. And I hope you remember that a squared minus b squared factors into a plus b times a minus b, where a and b are the square roots of the two terms that are being subtracted here. So notice we have the same pattern here. We have the difference of two perfect squares. So what's going to factor into a plus b times a minus b, where a and b are the square roots of x squared and 81. So this will factor into x plus 9, since x is the square root of x squared and 9 is the square root of 81. So it'll be x plus 9 times x minus 9 is equal to 0. So now we'll use that zero product property that says if I multiply two factors together and get 0, one of those factors has to be equal to 0. So either x plus 9 equals 0, which means x would be negative 9, or our other factor, x minus 9 equals 0, which means x will be positive 9. Now, there would be other ways to solve this equation, but if the directions say to solve by factoring, that's the way we would work this problem. Now, I wanted to show you one more example. There's actually not a problem like this on the summer assignment, but I just wanted to mention it because it will happen from time to time in this course. Sometimes you might have a quadratic equation that you need to solve where the trinomial is not factorable. If you take a close look at this trinomial, the constant term is 5. The constant term is 5, and try as you might, you're not going to come up with any factors of 5 that add up to negative 7. So if you cannot solve a quadratic equation by factoring, you'll have to use another method. And I just wanted to remind you of a method you would have learned in Algebra 1, and that is using our friend the quadratic formula. So the quadratic formula says to solve an equation of this form, ax squared plus bx plus c equals 0, we can find the solutions by using this formula. X equals the opposite of b plus or minus the square root of b squared minus 4 times a times c, and that's all over 2 times a. So since this equation is not, this quadratic is not factorable, let's go ahead and use the quadratic formula to find those solutions. So to get started, let's identify our a and our b and our c. Well, a is what we call our leading coefficient. It's the coefficient of the x squared term. Now, even though you don't see it, it's invisible, that coefficient is 1. So let's just write down that a is equal to 1. Okay, b then is your coefficient of the x term. So our coefficient of our x term in this problem is negative 7. So b is equal to negative 7. And then c is your constant term. C is the constant term, so in this problem our constant term is 5. So let's write that down, c is 5. Okay, then we just plug those numbers into the quadratic formula. We would have x equals the opposite of b. Now, the b is negative 7, so its opposite, the opposite of a negative 7 would be positive 7. So we'll write 7 plus or minus the square root of, remember b was negative 7 again, so that would be negative 7 squared minus 4 times A was 1 and C is 5. Sorry, it's getting a little squished there. And that is all over 2 times A. A again was 1. So now that basically represents our two solutions, but you might want to simplify a little bit. So let's go ahead and do that. So that would be equal to 7 plus or minus the square root of, well, negative 7 squared. Negative 7 times negative 7 is positive 49. So that would be 49 minus 4 times 1 times 5 is 20. And that's all over 2. And then a little more simplifying, we'd have 7 plus or minus the square root of 49 minus 20 is 29, all over 2. Now at that point, we can stop because 29 is a prime number. We're not going to be able to simplify this radical any. So we can stop there, and I just want to point out that this actually represents two solutions because of this plus or minus. The two solutions are 7 plus the square root of 29 over 2, and the other one would be 7 minus the square root of 29 over 2. And that happens when you have a quadratic that's not factorable. You'll get an answer like this that are actually irrational numbers. They're still real solutions, they just happen to be irrational numbers. So again, you will not have a problem like this on the summer assignment, but I just wanted you to see how to solve a quadratic equation using the quadratic formula because it is going to come up probably once or twice throughout the year. I hope this video was helpful in solving quadratic equations by factoring. And as always, if you have any questions, be sure and come see me at school.